I guess we can start. So welcome to the Designing Efficient Background Processes talk today. I am very happy and excited to see so many folks are interested in background activity in the system. My name is Vikram Singh and I'm a program manager at Microsoft, and part of my day-to-day work involves working with many internal teams at Microsoft to help them optimize and evaluate potential efficiencies in background activity that they own in Windows. I also work with many OEMs to help evaluate and optimize some of the activities they introduce in the Windows platform. I'm very glad to be here today to talk to you about some of those potential optimization recommendations and also discuss the impact that background activity can have on a Windows system and eventually the user experience. I will also be discussing a bit about some of the new infrastructure improvements that we've done for services in Windows 7. That's pretty exciting, and I have a demo around that, so we'll talk a little bit about that. So at this time, I will request people to please hold off on any questions towards the end of the session. I have with me here a very senior developer from Microsoft who works a lot in the services area, and he will help answer some of these questions together with me. Thanks. So for the agenda today, I will work on defining background activity in Windows and talk about the potential impact area the background activity in the system can have on the system and eventually the user experience. We'll discuss a bit about selecting the right model. There is a rich set of infrastructures available in Windows already that can help and be utilized to develop either Windows services or Windows tasks. We'll be focusing mostly on those today. As I said earlier, we'll discuss a bit and have a demo on the Windows 7 trigger start feature, which allows services to be stopped and only started when certain interesting rare events arrive in the system. Additionally, I'll discuss about Task Scheduler. The infrastructure hasn't changed a whole lot from Vista, but it's already very rich in terms of the feature set it provides to help allow tasks to be optimized for system performance and energy efficiency. Throughout the slides, I will also discuss security and optimization recommendations for both services and tasks. So what is background activity? Generally, background activity is any activity in the system that a user has not directly initiated. Although it does not mean that that background activity is not critical to the user scenarios. We all are very familiar with some common user scenarios, such as being able to search for files quickly on the system, whether it's pictures marked with certain user metadata or it's documents based on author name and things like that. So there's background processing happening all the time that is making these scenarios available and ready quickly for the user to be able to use them. So the Windows search service is one of a good example in Windows, which does search indexing actively in the system, mostly when the system is idle. And there's other system management related activities, both in the customer as well as in the enterprise arena, where in an enterprise, security policies might be deployed in the background using the group policy service, for example, which deploys both security settings for the machine as well as the user profiles. And then there's device management. The PNP subsystem manages multiple devices, and there's user mode and kernel mode driver services that help manage devices on the system. So there's tons of background activity happening, which eventually enables these cool features that the user is able to utilize. So the impact of background activity as part of, as I said earlier, some of the things that I do with many of the teams at Microsoft is look at 4 key areas, and I'll be discussing those one by one over here, is obviously performance. Background activity, when combined together, can have severe performance impact in terms of the user experience. So consider this: if the search service were to actively be indexing all the time and have high disk usage rate while it's indexing, a user might not be able to do simple operations to in a timely fashion to be able to maybe save a simple notepad or a Word file on the disk. So background activity should be intelligent in most cases to back off when required and optimize its activity to do only high priority items when required. And then again, there's scenarios like boot, shutdown, and the base system footprint while the system is up and running. Everybody doesn't like their systems taking too much time booting because there's so many non-critical boot processes that could be potentially delayed to a later time, but they are all part of boot today. So we all want them to go away and kind of move to only when required type scenarios. Reliability is another area. So since background processes generally run in system privileges in many cases, and a small problem in one of a background process can end up taking down the whole system. If, for example, the Windows Update Service, which is a local system service, were to crash frequently, then a user experience would be, they had to end up rebooting their computers unnecessarily. So background processes should have high reliability around their own execution, as well as client applications that are dependent on these background processes to act as servers. Those client applications should have reliability in terms of their client API calls or other scenarios that they depend on. So who's familiar with the blaster attack? Quite a few people. So this was just a quick summary. This blaster attack was an attack that was found out in the RPCSS service, which is a Windows service, and it was a low privilege service, but there was some elevation that happened via the blaster mechanism, and the whole system was compromised. So what I'm trying to get to here is that security for background processes is very critical, because many of these, like the earlier examples that I quoted, like the Windows Search Service or device management services in the system, they all run with very high security privileges, and it's legal that they require to do so, but there are certain things that they can do to optimize for the security scenarios as well. So one thing on security is that the system being compromised means the user data being compromised, and we are all quite familiar how that hurts organizations and even users today who want to store critical data that they own, and they don't want security vulnerabilities to be misused by potential hackers or processes. So another area that we look at now, everybody's wanting to maximize battery life. Organizations want to maximize battery life. Organizations also want to reduce desktop power consumption. And if you would have attended an earlier presentation today where Pat Stimmen was talking about battery life efficiency and what we can do about it, the deck should be available on Microsoft PDC. So there is some great talk on why this is important, and specifically idle efficiency it's the base footprint when the system is just sitting there. I'm not doing anything on this system, but the system is still, there is activity on the system that is spiking the CPU, that is doing disk I/O all the time, and eventually it's hurting the battery life on the system, right? Similarly for the desktops. So there are certain recommendations that we have for processes that the idle activity on a system should not target more than 2% of CPU processor time. And disk I/O should optimally be as low as 0. No disk I/O when the background activity is doing almost no operations. So as part of this whole optimization, opportunities, evaluation, and all this activity that we do at Microsoft, we also look at our own house at Microsoft, and we say, okay, what are the opportunities here? Where can we do better? And in Windows 7, we took a very critical look at about 100 or so services that are mostly running all the time since system boot. And we found out quite a few services that we were able to find out opportunities to optimize, either get them moved away from auto start to new infrastructure trigger start that I will talk about, or also optimize their normal duration running scenarios. So it's optimizations both for performance as well as security. Additionally, during this review, we found out about 49 or so services that are pretty critical for their own usage scenarios, whether it's media sharing or network discoverability, things like that. But they are not critical for boot. So we are actively working in trying to get optimizations around more services. We all understand that this is not a single release thing that can be achieved, but we are definitely targeting good optimizations around there. So this is some of the combined footprint data that you can see for these group of services. The file I/O operations when a system is running and doing nothing is around 47,000 operations. The copy on write pages is around 18 megs. Memory pages around 60 megs in use. Registry operations whopping 38,000. Threads 367. So quite a bit of impact is what we call, when the whole system combines with many services, many background processes, what we call as death by 1,000 cuts. So we work with many OEMs who are our partners and enterprises, and we did an evaluation for one of our big enterprise partners, and we found out that we did a comparison of the clean IT image, the clean Windows Vista image and the IT deployed image. And in addition to the 10 third-party services that were installed by the enterprise, there were some startup software and startup scripts that were also deployed. And these are some of the key metrics that we saw there. The boot time was almost double in the IT image. Shutdown time was slightly higher, around 30 seconds. Now, the idle CPU utilization is where it really counts, and the disk read count is another metric. These are the things that don't let the system go to low power states and thus increase battery life and reduce desktop power consumption. So the idle CPU utilization, which we recommend to be lower than 2%, was at a whopping 6.04% in this case, and the disk operations were around 3 times of 31,000 operations. And this is metrics that have been taken within the system, within 2 minutes of the system booting up. So you boot up the system and there you go, you have so much activity going on already. So what are the key things to look at when we design for efficient background activity in the system? The number one thing is try to find out what infrastructure best suits the activity that we are designing for. So whether it should be a Windows service because it goes across. I will talk about some of the attributes of Windows services that are better suited for service designing and some for tasks. Leverage new Windows infrastructure. We've done some security enhancements as well as the trigger start feature that I'll be talking about. Make performance optimizations for the case where the background process is actively running all the time. So do not have heavy disk I/O even when the system is not doing something. Try to have I/O optimized for the case where, like, people don't realize that when they're writing to the registry, that actually is causing disk I/O operations. So sometimes we don't realize that we are writing to the registry which is in memory, but at some point of time it does get flushed to the disk registry store. So writing to the registry is equivalent to churning the disk. Making security optimizations is also very critical around services and tasks. We have certain built-in security privileges like local system, local service, network service that are available. What the recommendation is here, there are certain system privileges that are very high privileges but are easy to use because they give you pretty much full access to the system. But then again, if there were a potential vulnerability in such a process, then the whole system can be taken down. So try to reduce to have only the level of privileges that would actually make the scenario work. That's the recommendation there. And evaluate and measure. There are certain tools that Microsoft provides. I have them listed out in the reference. use that to evaluate and measure the metrics for your background activity, and iterate until we are happy with the performance and security goals for the activity. So Windows out of the box has multiple services and tasks today. There are attributes of services which are better suited for service type activity. Some of the examples are like the Windows search service indexes for all users. So it has to run in a context that is not user context, and it runs in a local service or local system type context. There are other scenarios where there is intermittent activity in the system and you just need to have certain thing done and then get out of the way. Tasks are generally better suited. Also, tasks are better suited to things where you need to do user specific, user context based activity. There are some examples. Maybe an organization wants to update user certificates on user logon, so make sure that the certificates are up to date, things like that. So the service control manager is the infrastructure that manages services, and there is a programming model around it that's documented on MSDN. We will be updating it around the beta time frame for the new support that we have in Windows 7. That's what we recommend for programming services. The other thing that is a big recommendation here is for app compat reasons. Even though there are certain registry locations that are publicly visible, we still recommend very highly that people use the known public MSDN APIs and the built-in command line tools such as sc.exe to configure or create their services and manage services, basically. So how many of you are familiar with the Windows Vista tablet PC service, or just Windows Vista, for example? Okay. So some of you might have heard already in some sessions the tablet PC might have been discussed. The tablet PC service is a service that's there in Windows Vista. It's running all the time, independent of the fact whether an actual ink device or a digitizer device, as we call it, is attached to the system. What the tablet PC service is doing is actually it's sitting there listening for this rare event of a device being plugged in to the system. And when it identifies that that digitizer device is plugged in, it then enables inking functionality. So this was one of our key motivators from Windows Vista and previous operating systems, that many of these services have to do that unnecessary job of listening to rare events, right? And we wanted to somehow make this an infrastructure level support where services are stopped, and I'll be talking about that a little bit more. But in the meanwhile, when that support was not there, this auto start service type basically solved the problem for services. So service is running all the time. It's waiting for that rare event. Maybe it's 3 o'clock in the morning for Windows update, or it's a device event for a digitizer device or a Bluetooth device. And it's also easy for developers. The service is there available to service its clients all the time, the API set. So but there are the known problems. The boot time gets added. Service now has to start up along with 50 other services, and the system boot time is now extended. The base footprint of the system, like I showed in the previous slide, around 49 services combined to a good amount of footprint in terms of the system. So in Windows 7, we have introduced a new concept, which is the trigger start, as we call it internally today. The trigger start functionality basically is supported by the service control manager infrastructure that manages services. And what it does is it listens for certain known interesting events in the system today via the actual providers. So for example, the device arrival event is actually provided by the PNP infrastructure, and then SCM, the service control manager, listens for it, and then it is able to start any services that depend on that notification. We have further fine-grained support within the device event to be able to specify only certain categories of devices that the service would be interested in, and then start it on. So like in the system, there is the USB class, which is a very generic high-level class. You don't want maybe a scanning service to be started on any USB printer which is not scanning capable to be started. So the service can actually specify further detailed payload data, which will allow the service to be started only when a certain hardware ID type, which uniquely identifies that class of device to be started up. Additionally, we have the IP address arrival and departure. One thing I should note that even though I do say trigger start, the support is for start as well as stop. So services can subscribe to stop action as well on some of these interesting events. So the IP address arrival and departure notification allows services that need network connectivity to be only started when the network is there. So when I'm in a plane, many of these services can actually stop, and if they don't need to be downloading updates, for example, while the machine is not in the network. Other cases are where enterprises have certain services which depend on enterprise scenarios. These services can be triggered when the machine is joined to a domain, and the service can also be stopped when the machine is unjoined from the domain. We have certain Windows services that are utilizing some of these triggers. I have examples later on. And then the group policy updates is an interesting one, where services are interested in only specific group policy type updates. A good example would be in many enterprises, there is this whole BitLocker type secure storage concept where certain group policy gets applied, and the service now needs to apply those security policies for devices that are attached to the system. So the group policy updates is a useful trigger for services. It allows user as well as machine level policy updates triggering. Then we came up with the realization that many of these services have very unique triggering requirements. So it's very specific, it's very narrow requirement that the service developer, the scenario developer has. So we came up with the custom ETW event, where the scenario developer can actually be the provider themselves from wherever in the system they want to provide this interesting event, that rare event, and then the service can depend on that event tracing for Windows ETW event. This is documented on MSDN, and the service can be triggered off to stop or start as required. So some of the examples are the tablet input service and the store service, which is, you won't find the store service on Ultimate because it's an enterprise only service, so the enterprise queue has that, and it's only turned on when certain group policy updates are applied. Okay, so for the demo, so this is a very simple example of a small managed service that could in the real world be anything like a scanner management service or an imaging device management service, and it could do more functionality than what I do here as a demo. But for the purposes of the demo, what the service does is it has a timer which every few seconds basically looks for an attached USB device in the system, and once it finds such a device, it immediately copies the contents of that device to the hard disk location on the laptop. So what I'll do is, first I'll take the service, I'll create the service, and I'll show you the footprint that it has while it is running, doing nothing, just the timer code there. And then we'll go ahead and make this service change from the auto start type and always running type to be trigger started. So in that case, the service will be stopped, and only when I insert the USB device, the service will get started. So this is the timer code. Can everybody see this? Okay. And this is where we enable the timer. And when the timer event happens, we basically loop through all the drives in the system, and we find a removable drive type which is not of CD-ROM type, and then we assume it's a USB drive, copy all the files from there to see pictures. So I'll go ahead and build this. And I have certain scripts here which will help me register this as a service with the service control manager. So we made a call for create service, and now we are starting the service. So as you can see, the service is indicated that the start is pending. We'll go back one more time and check the service status one more time, and the service is now running. So this is the services.mmc UI, which lists the services, and this is the USB file service that is now listed as started and automatic. So if I open up Task Manager to see some basic footprint information, I can already see that the service is consuming around 1600K of memory. So I'll go ahead and insert the USB key, and the files that are there on this should get copied over to this folder right here. Okay, that's the autoplay notification in Windows. So it was pretty quick. The files got copied over, and if I go back to the USB key, the files are not there anymore. Great, but the service has now done its job, and it's pretty much just waiting again for 2 days back down the line. I might insert the USB key one more time, and it's doing nothing. So this is where we want to trigger such kind of services only when USB keys or other interesting devices or events happen in the system. So what I'll go and do now is I'll stop the service, and I'll modify my code to copy the file only when the service is started, and I'll remove the timer code. So we don't need the timer code anymore. Once the service starts, it will do the copy itself. So the service is now stopped, and I am copying the files over, moving the files over. So I have another script here that will call the built-in sc.exe command line tool that manages services, helps manage services. The tool uses the API that is going to be publicly documented on MSDN, and we recommend all service programmers to call that MSDN API in their service installer program. So this is the call to change service config to. What we are doing here is we are specifying that there is a device GUID of 53F5, that big GUID there. When that arrives, and the specific subtype of the device ID is USB store gendisk, only when such a thing happens, then this service should be started up. So programmers can use the other triggers that I listed earlier on, and can use either the queries change service config to API, or they can use the sc.exe command line, but we definitely recommend the API to be used for installers, and they can specify the other domain IP or even use custom ETW triggers. The sc.exe tool has been revved up to document these triggers, so doing a question mark will help answer some of the default questions on the triggers and the types. So now the service is stopped, and it is registered with the service control manager as a trigger start service, and the trigger data for that service is in the configuration that is in the service control manager's registration database. So now we'll go ahead and insert the USB key. Before we do that, we'll quickly check the status here, hit refresh. So now you can see, probably it's not very visible, but what it says there is that the service is now set to be of type manual, which means the service won't start up anymore with the Windows boot start, which is a great thing. And the service is stopped. So now I'll go ahead and insert the USB key one more time. Okay, that's the autoplay, close that. And the folder has the same set of pictures. Now if you look at the status of the service is now running, which means that it was actually triggered on the device being inserted on the system. So I believe that's pretty cool. Thanks. So one thing I have to note here is that this is a simple scenario where a service needs to be triggered, started, or stopped on one event. There may be certain cases where there is a complex set of rules that the service needs to decide whether it really needs to start or stop. That kind of logic should be built upon in the service code itself, not the service control manager, because there's no way it understands the complexity of the different kinds of rules that might be needed. Additionally, one interesting thing that is not in the builds right now, but we are considering more triggers, and you might be able to see them when we have finalized on the list at beta time. One of the interesting ones is the firewall trigger support. It's under consideration. So services that depend on certain firewall ports being closed or opened, they can utilize that. So here are some examples. The list is actually bigger, but I chose these set of services on the different trigger types that we have in Windows. And we all understand the fact that to provide new value, new features, new exciting scenarios, there will always be a constant need for teams to introduce background activity in the system. That is an undeniable fact. The only thing that we want to do going forward for the new services, whether it's in-box Windows services or OEM services or ISV services, we want to optimize them by default, and if possible use the trigger sets that we have. So that's one of the good things that you will see in Windows 7. Any new services that we have, many of these services are actually already using the trigger support that we have. A great case is the sensors MTP monitor. This is a sensor based, like GPS device sensor location information and things like that it helps manage. And this device is by default turned off unless you actually have such a device attached to the system. So it's not like the Vista tablet PC case where the service was just running all the time. Some other examples are the Bluetooth service and the tablet input service. And then the AE lookup service is an application compatibility thing that Microsoft has for applications that might not work properly, and they figure out certain things to be able to make them work. They have certain unique requirements on ETW triggers. So they implemented their own ETW provider, and then the service was the subscriber for that. So the service only starts up when that unique custom ETW event triggers. So here are some recommendations that we have on shutting down the service. Before I go there, I would like to note that once a service is trigger started, at that point of time, its base footprint starts adding up to the system. And again, like we saw, the USB service was now started up. And there are scenarios where the service will need to decide on when it can go down, when it can shut down. And those depend on many factors, such as the frequency of client calls coming into the service. So if a service has a high availability thing once it's started up, then it may never go down. That's okay. But there are other cases where certain services and processes can actually, based on certain idle criteria, can shut down themselves. This criteria is unique to the scenarios that the service caters to. So it's not one size fits all kind of a criteria. So service developers should figure out what is the scenario where they will be able to shut down the service or not. The other recommendation that we have around services is they should not accept the service except shutdown control notification. This is because once a service indicates to the infrastructure that I want to receive this message, then the infrastructure has to wait for the service to cleanly shut down. And what happens in many cases, the system has a hard limit of around 20 seconds where the whole system and even the infrastructure will be forced to go down, right? And in this case, we will cause unnecessary delays where the infrastructure is waiting on this service to cleanly shut down. So there are things, optimizations that services should do around not having too much work delayed until the actual service shutdown happens. So do not cache any cache data until the service actually goes and shuts down. Try to have that cache data saved to disk at an opportune time. And also, if you're running, if the service is running in an independent service host, then it's okay to not free memory. No need to free memory. And the goal around, the target around service shutdown notification is 200 milliseconds. That's the number we recommend for services. So another critical issue is with the service control handler. This is the handler that the service implements, every service implements. And inside the service control handler, we do not want any blocking calls. So it's always good if you have heavy work that needs to be executed inside the service to delegate such work to a thread pool type of thing. Do not have log-based code inside the service control handler. Once you receive the service control stop, this particular order is very critical to services. You should set the service status to service stop pending, and then if there are any stop work items that need to be executed for the service, post them to the thread pool. So this order is very key for a clean service stop process. Also, there's MSDN guidelines available for service control handler. So here's a sample security managed code that we have. Before I talk about the managed code, what I need to discuss is that there is the concept of local system in the services arena. And local system is a very high security privilege that pretty much has full access to the system. As far as security goes, it's almost running like the kernel. Although the reliability might be a different issue there, because a process running in local system may not always be able to take down the whole system. But as far as security goes, a local system process is like the kernel. So there is there might be some confusion there in some cases, but it's like the kernel. The recommendation around the privileges that services need to have, as I said some slides earlier, is do not have privileges attached like the local system to services unless there is a real need to. And in some other cases, as we'll discuss later on, there is certain splitting that can be done. Certain high privilege activity can be local system, but not network facing. So potential network vulnerability will not be compromised. And the network facing process can be a low privilege process. Additionally, even when running with low privilege processes, low privilege security privileges, one thing that we should do here is to strip any unrequired privileges such as the SE impersonate that come default with the local service and network service. So stripping them is a great idea, not having them if not required. So the third thing to do here is when configuring the service, always specify exactly what privileges are required for the service, and the infrastructure, SCM, takes care of stripping all the other privileges. So one great benefit is across OS releases, if you always specify the privileges that you need, even on the new OS, if there are new privileges that were added, they will not automatically be attached to the existing software. Additionally, in Windows Vista, we introduced the concept of service SIDs. This is a great feature that helped prevent many vulnerabilities, and it was actually, it's in the process, I believe, to be ported down to XP as well. So service SIDs, what it does is it assigns a unique GUID as a service token to the service itself, and it's based on the service short name, and it's unique for each service. What service developers should do, I should note that this is an optional feature, it's an opt-in feature, so service has to actually go and opt into this. Once the service opts into this, the service developer can then go and specifically ACL resources on the system to give access for that service, SID. So if there's registry locations or file locations on the system that only your service needs to access, then you can ACL them as such. And with that, even when the service is running as a local service like many other services, this particular service will be the only one to be able to access those resources on the system. Other local services, even though they have the same privileges, but they won't be able to touch the other services' resources. So it's a great security thing that service developers can use. Also, SCM guarantees the security privilege uniqueness on this, and it's not something that can be spoofed so easily. So moving on to some of the task scheduler infrastructure that we have in Windows. I'll start off with a small example of a new task that we are introducing in Windows 7. This is a task that the kernel power team wanted to have because they had the scenario where they wanted to find out about power issues on the system over a period of time. So, if the drivers are not correctly installed or not the right versions, and there's problems with energy efficiency on the mobile systems because of that, they want to find out about them. Of course, this is an optional thing that if only the customer is actually opted into the customer experience improvement program, that's only when this particular task is able to upload data back to Microsoft. So it runs this problem analysis powercfg.exe tool every 2 weeks, which is quite infrequent, and it only runs it when the system is idle. So it doesn't come into the experience of the user working, and then suddenly there is this power diagnostics task that starts executing. So many Windows tasks you will see will be marked to run as idle, and that helps improve the user experience where they don't run when the user is interacting on the system. So the idle definition that we have in the system, how the kernel identifies that the system is idle, is that there is 0% CPU activity and 0% disk activity for the last 15 minutes for 90% of the time. That's the definition that the kernel has for idle. And once the system matches this criteria, the system is declared idle, and any activity that is to be triggered off on idle, such as this task, will be triggered off at that point. So the task scheduler infrastructure has the concept of triggers and conditions. Triggers are what help launch tasks when certain criteria are met. These are the set that is defined here. The calendar trigger is basically a schedule trigger where a task could say, I want to run every 2 weeks, or I want to run every 2 hours. A good example is the Windows defrag task that runs, I think, about every week, and only when the system is idle though. Then there's boot and logon triggers where certain security checks, certain user-specific activity might be deployed by an IT enterprise admin, and they would want, if the user logs on, then maybe they want to have some interactive experience of a dialog pop-up or a tray icon, and they can do that via the task scheduler infrastructure. Such as you don't have critical updates on the system, please go ahead and click on this link to install those. Then there's the idle trigger, which is based on the idle condition that I mentioned earlier, and activity can be triggered once the idle condition is met. The event log based entry is pretty useful for those cases where there is a service that might trigger certain critical logging in the system, which is of warning type or error type, and maybe an admin wants to be notified the moment service logs such an error, and they could write a task where it could be based off event log entry being generated, and the task could do, I don't know, an SMS or an email to a known set of people so that they can immediately look at the service issue. The workstation lock and unlock are two other triggers that we have where certain activity might need to be immediately executed once the workstation is logged or unlogged, and it guarantees that that happens. So we have the triggers and we have these conditions. These conditions work together with the triggers to actually help decide whether the task needs to be executed or not. Once the trigger condition is met, these conditions are the ones that actually help finally decide if the task is now needed to be executed. These are meant to help optimize the efficiency aspects and the power optimizations that I've been talking throughout about. So the idle condition, you will see this in many Windows tasks and is highly recommended to be used. This is if, for example, the Windows default tasks wants to run every week, but it doesn't want to start if the user is actively working on the system, then they can additionally specify that, which they do that today, to say if the system is not idle, then don't run me. Additionally, if a task is already started, but the system is now not idle anymore, then the other setting of stop when not idle can be utilized. Then there are the two other settings, which are the AC power only. So if a task does not need to run when the system is on battery, then please enable this setting. And again, when the system moves from AC to battery, you might want to stop the task if it doesn't need to be executing, then the other setting helps that. There's another interesting setting that I don't believe any task in Windows uses, and we highly recommend anybody not using it, because in many scenarios people think that it's pretty cool to wake up the computer from sleep, but I don't want to be woken up for anything when I'm sleeping. So my laptop is right there next to me, and I don't want the disk churning, and I'm pretty sure most users are like that. If they've shut down the computer, it's for a reason. Right. So there's folks that have valid scenarios like Media Center mentioned here where they need to use it, but in that case I would probably have my Media Center machine in a different room than, So by default in Windows 7 on mobiles, the setting for the API set waitable timer, I believe that's what it's called, is the one that's even if you call it for mobiles, the setting is disabled by default, so it will have no effect unless there's a control panel setting where you explicitly go and enable that setting. So this is for us to encourage folks to not use this setting. Then the other setting that we have is, again, if a task needs network to be able to download critical updates or things like that, then there is the specific or any network. So a task can actually be triggered off a specific network availability, or it could also say, I don't care about a specific network, as long as any network is available, I should be executed. So that condition can be utilized also. So the recommendations for tasks are: use the idle condition to not interrupt the user experience and only have activity when the task is when the system is idle. Enable the power condition to help optimize the battery life and the desktop power consumption, and enable the network condition to do any network based activity only if a network is enabled. So downloading software updates is a good example there. So to reiterate, performance in Windows is critical for these key areas. It adds to the base footprint of the system. We don't realize that the process by itself might have a small footprint, but when we have these tons of Windows applications, ISV applications, OEM applications, they all contribute to maybe not so optimal user experience. That's why wherever possible, we should try to reduce and target for idle efficiencies, right? Always back off if the user interactively is working on the system and they're trying to maybe just write a Word document or do their development, or so we don't want other activity to come in their face at that time. Power consumption is also a direct impact that background activity has in the system. Pat's talk actually digs quite a bit into that, so I would highly recommend you to download that slide deck and go through it. Talks about the ideal efficiency differences and how the CPU spikes up to very high wattage usages in case of moving slightly above in utilization. So the target should be less than 2% CPU activity. This is a number that has been questioned by folks on where did we come up with this number, and Pat mentioned this earlier on, is in Windows Vista, we have seen that the number is around 0.7%, and we think it's a safe recommendation to make to folks to not go above 2%, and that's why we say 2% here, and no disk activity if the system is idle. The disk not stopping, not churning, not going down causes good amount of power utilization on the system. Xperf is the tool that helps measure performance. It actually, there was a hands-on lab earlier on today, and it might be available online as well, I believe. It helps debug exactly what functions inside an application might be causing more activity, so you can dig to that level of detail. I have the reference later. So I would like to close the talk mostly today and basically have these recommendations one more time. We have to understand that background activity mostly has quite a bit of impact, real impact on user experience. It has performance impact, it has reliability impact, it has security impact on the system, and it also has power efficiency impact. So we recommend to use the Windows 7 trigger start wherever available, and also decide whether a task is better suited than a longer running service in many cases. Security, always configure the service to be using the least set of privileges required. It's not an easy task to identify what are the privileges that will suffice for, but that will always guarantee that the service is not prone to vulnerabilities that are unknown at the time of the development of the service. Also, use the task settings that we talked about earlier on about idle, power, and network, and then use the Windows Performance Toolkit that helps evaluate and measure the footprint of your application. So here's some additional resources. This paper has been recently developed, the first link there, and it digs much deeper into some of the benefits of tasks and services and some of the guidances that we have there. This paper is going to be available, I believe, after WinHEC. So that's the link location that's currently there. And then there's some already existing good documentation on services and tasks. And the last one is the measurement one, where Windows Performance Toolkit can be used to measure application activity performance. So thank you for coming to this. I hope you had a great PDC experience. Please fill out the evaluation sessions. And Chittur will join me here if you have questions. We have about 20-25 minutes. I sped up a little bit, I guess. So.
Hello. Hi, Vikram. Good presentation. Quick question. How does that work with service dependency? How do the trigger start work? If you got a service that's start, auto start, and depending on service, that's trigger start, how would that work?
So the dependencies are pretty much handled exactly as before. For the start case, the dependent services will be started first, followed by the triggered services. And for the stop case, we will actually take down the entire tree when we have the trigger. So if you use a stop trigger, the entire tree will be taken down as part of the trigger stop. And for the start case, it will be basically as before. That is, if your service A is trigger started, it depends on service B, then B will be started first, followed by A.
Okay.
So trigger start, you should consider trigger start as a demand start.
Yeah.
So assume that your service start type is changed from auto to demand. And how you would handle it is very similar. Only thing is the system provides additional support to optimize performance, security, reliability, and the other measures we have talked about. So it is very, very similar to demand start, except that where in the past you did not have control over events that happened in the system, and there was no way for you to start when a device arrived, for example. So we had to plumb in the entire stack to make that happen, all the way from the kernel mode PNP to user mode PNP service and so on. So these are basically giving you hooks to convert your service from auto start to demand start. But as far as the behavior goes, it's very similar to demand start.
Okay, cool. Thank you.
Will there be any programmatic access to the service control manager so that a non-admin user can programmatically start a trigger service?
Sure. So you have a service security descriptor, and you can set a service security descriptor using set service object security API, and you can specifically say that
Allow
whatever user you want to start the service, you can specifically add it there.
Well, I'm thinking more of the situation where right now I leave my service running because I don't want to force non-admin users to start it. But if with a trigger service I can pretend that it's running and just have a user mode, just a ping to see if the service is there, and have that be a trigger to start the service.
I see. So so the way the trigger start works is the service control manager is actually starting on behalf of your trigger. So it is not like the client coming and directly starting, because we had to split the client action from the service startup. They are disjoint events. So the security does not really directly apply. So the event happens and the service gets started because you told the infrastructure to do so. It's not as if a virus or something is coming and starting the service. So the key there is that the events that you generate have to be secure. In other words, if you are specifically for the events that we already provided, like group policy, IP address, and so on, either they are coming from the kernel or they are coming from local system user mode. So they are secure. So you cannot attack them. But if you are providing custom events, then you have to be careful to make sure that you have proper security descriptor attached to the particular ETW event. And there are facilities available in Windows, then you should take advantage of that. So that's one. The second one is if both your client and your service, right? If both your client and your service are both in user mode, then you may want to not consider trigger starting, because trigger starting is not necessary there. You could have your own mechanism and call start service, followed by the RPC call for it, the ping in your case, right? So trigger start does not solve the problems that you can solve with other mechanisms today. It is for the situations where you cannot do it today. For example, the USB is a good case where there is no way for you to do it unless you write a different service which listens for this USB. And that's pretty ridiculous, right? So you should use trigger start only for those cases where current mechanisms don't work. That is, you cannot use start service and things like that. Another example is you have the event coming from kernel mode, in which case there was no way today to start a service from kernel mode. And using ETW events, now you can actually start a service from kernel mode. And what we are shooting there is a large number of drivers in the system have got user mode counterparts. These drivers basically implement some functionality and have a user mode service which does manageability work. It listens to remote requests and things like that. So you have both these pieces running all the time. And the user mode piece is typically very problematic because it listens on the network by design, and it can be taken over at any time. So we are trying to at least kill that half of it, so that you can have the driver now set an event and start the user mode service. So you should use this, and we will have in the guidelines and the white paper that he has. If you go through that, you will understand these scenarios better. So use them only in the appropriate scenarios, not when you can actually use start service to start a service. If you can do that, kindly do that, because that's more straightforward and efficient. Then you have better control over security and everything. It's very, very tight.
Right. Kernel also start the stack task bin?
Yes, kernel can start a task through the Crimson event. So there is a way to start a task through Crimson event. Crimson event basically means event log event. So if a kernel mode driver generates an event log event, you can start a user mode service, user mode task.
In the back?
This may be a misunderstanding on my part. So the way I'm coming from is when you try to net start a service that's already started, it fails. So imagine that your service is shutting down and a trigger fires saying to start the service. The service is already started, so it says, oh, I don't need to restart it. But the trigger is missed because the service is shutting down.
Great question. Great question. We explicitly handle that because that's one that prevents a lot of services from shutting down because they are always worried that they will lose this trigger. So there is a new control we are sending called service control trigger event, which you will get for sure when a trigger arrives while you are running. So if you get that control, you know that an additional trigger has arrived while you are running, so you shouldn't be shutting down. You should reset your timers. So that's explicitly handled.
It's great that you've added support for the triggered services, and it's great that you're educating people here in this room. But what are you doing to get all these other people out, all the other ISVs out there that are not here listening today? I know a lot of them are abusing services for things like updates or even just, and this is not what you're talking about today, but even just the run registry key where they have long running processes. Let's get them running as scheduled tasks.
Right. We, as part of our evangelization, we have developed this paper that we want to make available to the key ISVs out there, and we are working with our application compatibility team, the team that works with many ISVs there, to make this information available. We are also having certain live meetings with ISV vendors where we are doing some surveys to find out activity that they are introducing in the system and what they like and dislike about being able to not do certain things and being able to do certain things. So we are actively engaging with many ISVs on that.
Great. Have you considered proactively contacting software vendors that you've seen complaints or maybe through the built-in Microsoft feedback mechanisms have seen, to be doing things the wrong way?
Right. We haven't contacted anybody on a one-to-one basis. It's mostly through our Microsoft program where there's an NDA and we talk to only a certain limited group. But I will investigate and see if we can do things on that end.
Great. Thank you.
Hi, I was interested in what you showed on assigning specific rights to services. And it looks like you're using sc.exe. Does that have to happen at install time, or can you do it afterwards?
You can actually, the sc.exe simply uses the APIs, change service config 2, create service, and so on. You can call those APIs at any time. Create service, obviously, you call it at install time, but you can change the service configuration anytime after that.
And that includes the rights that the service has?
Yes, that includes the security descriptor of the service. You're asking about the security descriptor, right?
Yep.
That is, when you put on that security descriptor on the service, it will control who can make API calls, the service controller API calls on that service, who can start the service, who can stop it, and so on. That you can set at any time after installation.
Now, I was thinking about rights like access to the network or access to the display or that sort of thing.
Okay, so in that case, I think you are asking about ACLing the objects that you are interested in. For example, what registry keys or what files that you want to access.
That's more what I'm thinking of, yeah.
Right, sure. So for that also, each of the objects have got set security API. So this set service object security is one of the such classes of APIs. So you have a similar API reg for registry, for file system, and so on. So you can set those at any time, after installing the service. It's not directly connected to it, but you would want to set it before the service starts up so that the service gets access to whatever keys it's looking for.
Great.
And what we have done is that we have given a unique identity on a per service basis. So now, using that identity, which is fixed across all machines, it's basically just based on the name. So using that identity, you get a SID based on that identity. And using that SID, you can ACL your objects using the APIs like reg, set key security, and file.
And all that goes through the SCM?
No. Those APIs directly go to the object manager. Whichever object owns that. Right? Registry means it goes to the registry. If it's file system, it goes to the file system. But what we provide is we provide the support whereby in the service process token, this particular SID gets added, which means that when the service is running and it tries to access it, and the NT kernel is trying to do an access check saying, is this service allowed to write to this key, it will go and check the identity of the caller, which is your service, with the object's security descriptor, and if it matches, it will let you in. So the service controller manager is responsible for adding the service SID to the process token groups list. That's what it does. And you have to do the separate step of ACLing your objects, whichever you are interested in.
Great, thanks.
I was wondering, have you seen a marked decrease in the number of services that are running now in Windows 7 versus XP and Vista? Has the number default on clean systems?
Right. So there are scenarios where the services will be started up. For example, there are enterprise scenarios where certain services manage those enterprise scenarios. So if a clean system is joined to a domain, there are certain services that might get started up in that case, but they will not start when it's not domain joined. So we have certain set of services that are already in the M3 builds, that the pre-beta builds that are available, that are stocked by default, and they will only be started, like the tablet service is not started, we have a list there. And we are actively working on getting more services, so the beta builds will have, once they come out, will have more services.
So yes, the trend is that we had a drastic increase in the always running service set from XP to Vista. But the trend has kind of changed now. So that it is a downward trend.
Yeah.
But we are not promising that, it will get back to the XP state, because a lot of functionality has been added in Vista which required services to be running. And what we have done is that for any new stuff that has been added in Windows 7, they pretty much follow this model, because there is no reason for them not to. The main reason why services might kind of be a little bit reluctant to use this is because of application compatibility. Because they had a set of scenarios that used to work before, they need to at least rethink those scenarios just to see that, oh, it works properly, right? So in many cases, they say their scenarios are so complicated, they cannot do it in one release. So in such cases, we have to do it in another release. But the plan is that, we want to get this not only in Windows, but also to, service owners, so that the customers have a great experience at the end of the day. And we all have a great reward for that, right? So that's the whole goal. But in Windows 7, the trend has shifted, but it doesn't mean that it is it's overnight everything is clean. We wouldn't claim that. But despite adding a lot of new services, new features in Windows 7, you wouldn't see a commensurate increase in service set.
In the back.
Regarding the recommendation not to exceed 2% CPU, does that apply both to tasks and services?
Yeah, that's a general recommendation that we are making for any activity in the system, to adhere to that guideline, because ultimately it's the system. As a user, when I look at the system that's idle, I don't want my system to be spiking up on resource usage.
What about a task that's scheduled to run during idle time? Wouldn't it make more sense to take full advantage of the CPU while it remains idle? Thus, when the user comes back, the task is done.
Right. So that's a great point. Definitely yes on idle. But then again, there are cases where the task does not need to be as frequent. So many.
I was considering something that maybe runs daily but is compute intensive, and
right.
thus could take advantage of parallelism.
If the scenario requires such a thing, then definitely yes.
Okay.
I think we'd want to separate. Sorry for jumping in. I think we'd want to separate maintenance or scenario activity from I've got a piece of activity or background activity that's loaded on the system and it's always running, not doing anything. So the 2% guidance is really globally for the system about I stopped using it, how much CPU does it have? And when you have a piece of maintenance activity or a piece of software activity that you purposely want to run at idle, sure, all bets are off. Go nuts within reason.
Okay.
Yeah, you totally understand.
If I have a service and I want to write data to the hard drive, just a bit, say statistics, what's a clever way to do that? Because I don't want to do it every 2 minutes. That would be horrible for the hard drive. It never powers down. I don't want to do it when it's idle. I sort of want to do the opposite, right? I want to write it when the hard drive is busy anyway. Is there a clever way to write data to
So
the hard
Pat
drive?
has some good information on that. Do you want to use the mic there?
Yeah. Sorry, I happen to know the answer to that one. There is a power notification that comes from the power manager that says, hey, now's a really great time to use the hard disk because it's been spun up and it is spun up and the system's on AC power right now. So assuming your activity of sending those statistics is cheap in terms of CPU and other activity, that's a great notification. It's called GUID idle background task, and we can talk offline. I'll give you a card to get the call out for that.
Does it depend on battery or AC or anything? I mean,
It depends on AC. So it's only fired if the system's on AC power. So it says, it's a private notification that says, hey, you're on AC power and the drive's already spinning, so if you've got something small to do, do it. In fact, inside Windows, we have something called the reliability access component. You guys have probably seen the chart of reliability over time that we introduced with Vista, right?
Okay.
That thing uses...
It answers the question.
Yep,
Thank you.
yep.
Okay, any more?
I have another one, but I just...
Okay, I guess you can.
Nobody else?
Yeah.
There was an option that in the schedule task that you run something when the machine is idle. And it also had the option to stop it when the machine is no longer idle. How does that actually work? Do you call kill process or how do you do it?
Basically, what we do is we try to do the regular WM stop. On
So it's
that,
A Windows message, right? Okay.
for
Right.
executables, yeah.
So if your task is a COM task, which is a COM server, you are supposed to implement a stop routine, and then we will call into the stop. So that's for COM tasks. If it is a plain old XZ, then XZs don't have any specific thing that we can call.
Right.
So the best we do is WM close. So we call a WM and close onto you, and then wait for you to respond. If you don't respond, there is an additional setting called allow hard terminate. And that allow hard terminate tells you that you are okay for us to go and terminate processing.
Okay.
Well, thank you, everybody.
Thanks.